The variety of phenomena in the universe can be described by four forces: the strong nuclear force, the weak nuclear force, the electrical force, and the force of gravity. These are the fundamental forces of nature.
Complicated and confusing world. There are, or so it would seem, many different forces at play. Nonetheless, scientists have sought to reduce these to one, or at the most, to a very few. Two fundamental forces dwell within the heart of the atom. Another knows no boundaries in the cosmos. And the fourth holds all matter together. The fundamental forces in the atomic nucleus are called the strong nuclear force and the weak nuclear force. The strong force binds protons and neutrons into nuclei. It's so powerful it can overcome the natural repulsion of protons. And this power can be released in nuclear reactions. Indirectly, the strong nuclear force sets fires deep within the sun and within other stars as well. And yet, as powerful as the strong force is, its range is so small that 12 zeros follow the decimal point to express it numerically as a fraction of a centimeter. The weak force, the other fundamental force within the nucleus, has effects that are by no means weak. Though its effects are subtle, they're very obvious. In the violent death of massive stars, for example, or in the decay of radioactive isotopes, a twist on alchemy that turns uranium into common lead. Increasingly, scientists are discovering how the nuclear forces link the past, the present, and the future of the universe. Yet, as much as is known about the strong nuclear force and the weak nuclear force, they remain somewhat mysterious. Hidden from the everyday world within the atomic nucleus, they remain among the innermost secrets of nature. The two other fundamental forces, equally wondrous and incredibly powerful, appear to be far less clandestine in nature, and they can be seen much closer to home. The most familiar fundamental force is gravity. Even in a commercial kitchen, the force of gravity accelerates mass. It came before both the chicken and the egg. But before Newton's law, people didn't know very much about gravity. They knew something about it, that it made things fall, for example, but they didn't know gravity makes the moon fall, nor that gravity, first and foremost, is a fundamental force of the universe. A fundamental force and an attractive force. As an attractive force, gravity can be described in popular human terms. Not only does gravity get around quite a bit, from one end of the universe to the other, it has considerable influence on everything under the moon. Far more than that, gravity relates to everyone and to everything. In a way, gravity reaches out and shakes hands with the entire universe. The fourth fundamental force is electricity. Electricity seems the paradox of the forces. 1 minute exciting, raw, and even frightening in its power. The next, as ordinary as a pop-up toaster. On the bright side, electricity is as common as white bread. On the darker side, it conjures up images, some deadly, some mythical, and all of them somehow plugged into the character of Western culture. No image strikes closer to the American landscape than this Philadelphian harnessing electricity with a kite. Considering his unequaled accomplishments, editor and writer, inventor, politician, postmaster, and statesman, philosopher, the wit and wisdom of his era. Why has this image remained the most popular to this very day? Because Ben Franklin was young America's first and foremost scientist. In the course of studying its effects, Franklin had the ingenious but not quite accurate notion that electricity was a kind of fluid, an electrical fluid contained in each ordinary body. If the body held too much of the fluid, Franklin said it was positively charged with electricity. A body with too little was negatively charged. Franklin's terms, positive charge and negative charge, remain vital in the vocabulary of electricity. But the significance of the electrical force goes deeper than his reflections. At its most fundamental level, electricity is the force between positive and negative charges. It binds together everything in the universe, everything from soup to nuts, including the kitchen sink. Since that includes humans, why aren't they aware of the charges in their bodies? Why doesn't bread electrocute toasters? Every time people shake hands, why don't they fry each other like potatoes? Because everything has equal amounts of positive and negative charge for a perfectly balanced blend.